Hi, this video is over section 3.3. This is for Math 1650. We're going to look at measures of relative standing and what's called a box plot, which is a graph that is going to be used to plot the distribution, and what's called the five-member summary. So first, some symbols. We've seen these symbols. I just wanted to go back over them. For a sample, you have the sample mean, which is x bar. You have the sample standard deviation, which is s, and the sample size, which is n. And then if you're looking at population, the population mean is mu, a Greek m actually, but it looks like a u. Population standard deviation is sigma, a Greek s, and the population size is a capital N. We're going to look at what's called z-scores, and we find the z-scores the same way, whether it's sample or population. It's just your data value minus the mean divided by the standard deviation, and it gives you what's called a z-score. And then we will use these z-scores later on to get probabilities. Right, so when you get a z-score that is positive, it means you're above the mean, above the average. If it's negative, it's going to be below the average, or below the mean. And if you can look at the formula here, x minus x bar, for this to be positive, x has to be higher than x bar. What we call ordinary z-scores are between -2 and 2. Right, so any kind of z-scores that is a -2 below the mean, 2 above the mean. Unusual would be when z is greater than 2 or z is less than -2. If it's less than -2, that means the value was way too low than what's considered average. And if it was greater than 2, the value is way too high than what is considered average. Alright, so we're going to look at a couple examples here. Given an IQ test with a population mean of 100 and a standard deviation of 15, what is the z-score for an IQ score of 135? So we'll do the x value. I'm going to write this out. X is 135. This is a population mean, so the population mean is 100 and standard deviation is 15. So 135 minus 100 over 15 is 35 over 15, which is 2.3. So you get z-score 2.3. This score is above the mean and is unusually high. Now, that doesn't mean it can't happen, doesn't mean it's an outlier, it just means it's unusually high. Okay. The author of the text measures his pulse rate to be 48 beats per minute. Is that pulse rate unusual if the mean adult male pulse rate is 67.3 beats per minute and a standard deviation of 10.3? Alright, so for this, our data value we're looking at is a 48 minus the mean, which is 67.3, over the standard deviation of 10.3. This comes out to be a negative 1.87. Okay, so this value is below the average, below the mean, but is not unusual. It's just low. Doesn't mean it's too low to be unusual. Alright. Let's go back to the drivers of the construction that get ticketed by the construction police. Okay, remember with this that we had a mean that was equal to let me just go back and check. Actually, I haven't unstepped this still. Column 3, mean was 46.78 and the standard deviation was 4.1. Right. We're going to look at what's called the minimum usual value and the maximum usual value. For the minimum usual value, you take the mean and you add 2 times the standard deviation. It's kind of what we did with the empirical rule of 95%. But this is the mean plus 2 times the standard deviation for the maximum, and mean minus 2 times the standard deviation for the minimum. So we're doing 46.78 minus 2 times 4.1 and 46.78 plus 2 times 4.1. Now, don't get confused. This isn't the minimum and maximum values or the highs and lows. This is based on usual values. So 46.78 minus 2 times 4.1 is 38.58. 46.78 plus 2 times 4.1 is 54.98. Alright, so drivers get ticketed. That doesn't look like an S. Get ticketed driving usually between 38.58 and 54.98 miles per hour. Since we can't actually, that's not going to be on the speedometer, we can always say 39 to 54 miles per hour. So a driver getting ticket at 35 is unusual. Unusual for a driver ticketed at 35 miles per hour. Doesn't mean it doesn't happen, just means it's not common. If we looked at the z-score for this, 35 minus the 46.78 over 4.1, we will get a negative 2.88. So it's much lower than negative 2. Alright, so now let's look at the blood pressure measurements. I'll go back and get the mean and standard deviation. That was in column 4. So mean, write this down here. Mean is 133.92 or 93, and standard deviation is 9.04. Right, so minimum usual will be 133.92 minus 2 times 9.04, and the maximum will be 133.92 plus 2 times 9.04. These values come out to be 115.85 and 152.01. So would a value of 132 be unusual? let's find the z-score real quick. 132 minus 133.92 over 9.04 gives us a negative 0.21. Okay, so now this value of 132 is within the usual value range or limits with a z-score of negative 0.21. Okay, so 132 falls between 115 and 152, makes it usual, makes it common. And that z-score falls between negative 2 and 2, okay, makes it common. And they will always align. Alright, so we'll move on to a new thing now. So actually, we're done with those data sets. So we're going to clear StatDisk because we'll be using it for other things. Percentile. Data is partitioned into 99 percentiles that range from the lowest value to the highest value. Basically, we're talking 0% on one end, 100% on the other end, and then 99 different percentiles in the middle, where 50% is here, 25% breaks that up, 75% breaks this up, and so on. We'll keep breaking this into 99 percentiles. To find the percentile of a specific point, we count the number of values less than that value, not equal to, but less than that value, and then divide by the total number of values in the data set, and then multiply by 100% to get a percentage. So if we look at the female pulse rates, what percentile is the data value of 96 in this data set? Well, 96 is all the way down here. Each of these has 5 data values, and there's 1, 2, 3, 4, 5, 6, 7, 8 rows. So there's 40, n equals 40 here, and it's the 38th. So there's 37 values out of 40 times 100%. 37 divided by 40 times 100, and we get 92.5, which will round up to the 93rd percentile. Given a data set, find the percentile pk. We're going to use this to find a locator for a given percentile. So L here is your locator or your position. K is the percentile. N is your sample size. Okay, so if we want to know the 72nd percentile for female pulse rate, we will find the locator. 72 over 100 times 40, so 0.72 times 40, and you get 28.8. Then we also have to go one above this, and we have to look at the locator for 73. So 0.73 times 40, and you're at 29.2. And then what we do is we're looking at the locator in the middle is the 29th value. Right, and so the 29th value here, we'll count it. So 5, 10, 15, 20, 25, 30, so it's be 80, right? 5, 10, 20, 25, 29, so 80. So P72 is equal to 80. All right, so now we're going to look at what's called a 5-number summary. And I want to specify what's called quartiles. So first quartile is P25. Second quartile is P50, which is also the median. Third quartile is P75. And it's going to make our 5-number summary be the low, the first quartile, the median, which is the second quartile, the third quartile, and the high value. Okay, so for the female pulse rate data. Now, the best way to do this with data set is to start breaking up in half. So break this into halves. We find the median by measuring the average of those two. So we get 74. Right, we can find the low value is 60 and the high value is 124. Those are the easiest. Okay. Now we have to break this each section into half. So we break this in half and find the average of 68 and 68, which is 68. And we break this in half and find the average of 80 and 80, which is 80. Alright, so that is our 5-number summary. 60, 68, 74, 80, and 124. Now, to find this on StatDisk, we have to type in the values, which do have to get that in. Let me go back up here. Actually, I'm doing our pulse rates. Let me see if we have. I'm not sure if they're the same. Low to high. So 360s, 364, 464s there. Yes. 4, 5, 68s. And 3, 6, 7, 8, 52s. And then 5, 6, 76s. Yep. And then 4, 5, 6, 80s. Yep. And 5 88s. Alright, yep. This is the column we want. So 11th edition female health exams. And so we can look at explore data, pick the pulse rate, and we can get our 5-number summary, which is the exact same thing we got. 60 for your low, 68 for your first quartile, 74 for your second quartile, which is your median, 80 for your third quartile, and 124 for your maximum. Right, so now we want to look at the box plot. Well, with the explore data, you can see the box plot. That's one way to look at it, but you can't change it any can't compare it to other ones, you can just look at it. There is another way we can do data box plot, and we can select the box plot. And again, it's the same one that we saw, plus this gives you the 5-number summary on the side. Right, but you can draw in the box plot for this. And I'm going to put in the values below 60, 68 is your first quartile. 74, 80, and 124. Now, let me go to mine. The 60 is that first vertical line, that's your low number. The 124 is your second vertical, your last vertical line, which is the high number. Then you make 3 vertical lines, that are your Q1, median, and Q3. And then you connect on the bottom and the top, the Q1 to Q3. So all the vertical lines are the same, making a little box here. What we are hoping to see is that inside the box is somewhat equally spaced, and then also the ends here that come off the box are kind of equally spaced out as well. Inside the box, it kind of shows that this is mostly normal. The outside being the last one being far off shows that that 124 is kind of an outlier, or maybe extreme outlier. Now, to find the outlier for this, go back to this, we can hit modify box plot, and we can see not only is that 124 an outlier, but one that I think it's 104 that's also considered outlier. Right, and so for the modifying box plot, it puts an asterisk, I'll do it in red, asterisk at 124, puts an asterisk at 104, and then the 96 here is your last one. It also takes away the vowels and the ends for some reason. That's just to indicate it's modified. So that's how the modified one looks like. All right, we can look at the Melrose pulse rate now. So let's go back to the data, clear this. Click on 11th edition male health exams. And we'll look at box plot. And we'll do a modified box plot with pulse. And for the males, it goes lower than the 60. Hold on, let's look at just the regular box plot report. The lowest is 56. And then 60, do it this way. 60 is your Q1. And then median is 66. Q3 is at 76. And 96 is your maximum. So I drew it in comparison with the female pulse rates. We can see our maximums at the maximum for the female when you take out the two outliers. Our minimum is below the female minimum. Matter of fact, our median is below our female's Q1 even. This is less normal. And then if we look at the modified box plot again, we can see that there wasn't any asterisks, so there's no outliers. All right, so it being modified, the only changes is they take the bars away at the end, and there's no outliers. Alright, so let's look at making a box plot by hand with some data that we can kind of do this easily. I know we can do it on Statist, but it helps going through how to do it by hand. We're going to look at these data. These are chocolate chips per cookie for 40 different chocolate chip cookies. I don't know how they fit 30 chocolate chips in a cookie, but they must be bigger. The low value, we'll look at the 5-number summary. The low value is 19. The high value is 30. And then we're going to cut this in half. And our median is 24. And then we're going to cut the top in half. It helps when they're equally spaced like this. 22 and 23. So Q1 is 22 and a half. And we'll cut this bottom in half. 26 and 26. So Q3 is 26. Alright, so 19. We'll do it this way. 20, 21, 22, 23. I just count to 30. Where I get kind of a scale here. That's your highest. Then we have bars at 26 for Q3, 24 for the median, 22 and a half for Q1. So that first line goes to Q1, below Q1, we make the box, connecting median and Q3, and then we take this line out to the end. Okay, and this is it's pretty normal. Maybe some deviation a little bit higher than that 30, but it's pretty close to normal. Okay. Alright, so we'll do some more with bringing in kind of what we've done in section 3.1 and 3.2 and 3.3 all together. I'm going to do this in a different video, so this video isn't as long, but we're going to do a few different problems in the next video that incorporates all of this, including even some stuff from chapter 2, which is your dot plot and your frequency distribution. And then the last thing in that video will be what's called coefficient variation. So I'll see you in the next video. Bye.